So, OpenAI is back with another great feature. The company's latest innovation, predicted outputs for GPT-4 and GPT-4o-mini models, is revolutionizing our interaction with AI. This feature supercharges everything from coding to content creation by fundamentally changing how AI generates responses. Instead of the traditional method where AI builds responses token by token, predicted outputs lets you provide a head start by suggesting what you think the response might include. Think of it like giving the AI a rough draft to work from, rather than having it write everything from scratch. This smart shortcut is particularly powerful for code editing, where OpenAI's tests have shown a remarkable 2- to 4-fold increase in processing speed. For developers and content creators, this means spending less time waiting and more time creating. And the best part? The quality of output remains unchanged. We're just getting there faster. The good news is that when working with extensive code files or lengthy documents, the impact is substantial. Tasks that previously took over a minute now wrap up in about 20 seconds, and that's more than a 50% reduction in processing time. This efficiency boost is transforming how we handle large-scale AI operations. The concept is quite simple. Instead of prompting the AI to generate everything independently, you can provide it with context about what you expect in the output. Imagine you're modifying a complex piece of code where only a few lines need changes. By feeding the existing code as a prediction, you're giving the AI a framework to work with. This way, it focuses solely on the necessary modifications, rather than reconstructing the entire code base from zero. This feature particularly excels in tasks with repetitive or predictable elements. Whether you're refreshing blog content, tweaking scripts, or adjusting large datasets, predicted outputs streamline the process. By informing the AI about unchanged portions, you're directing its focus solely to the necessary modifications, eliminating redundant processing time. However, there's an important limitation to consider. Predicted outputs aren't beneficial when creating entirely new content. If there's no existing framework or predictable pattern to work from, the AI needs to generate everything from scratch. The real power lies in scenarios with established baselines or repetitive elements. OpenAI has extensively tested this capability across various programming languages, including Python, JavaScript, Go, and C++, confirming its effectiveness across different coding environments. The results consistently show improved performance regardless of the programming language used. However, it's important to note that predicted outputs are currently limited to the GPT-4 and GPT-4o-mini models, with some key restrictions to be aware of. One notable limitation is the lack of support for advanced API parameters that you may have used in other scenarios, such as calling for multiple outputs at once or retrieving probability scores. Let's explore an example in TypeScript to illustrate the power of predicted outputs. Imagine you're refactoring a class called user and need to change the username property to email. Since the core structure of the code remains largely intact, you can feed the existing code as the predicted output to GPT-4. When you then prompt the model to make the necessary change, it will only update the single line required, rather than rewriting the entire class from scratch. This targeted approach significantly reduces processing time and improves overall efficiency. When the model processes your provided prediction, it keeps track of two key metrics. 1. The number of tokens it accepted from your prediction, which are rapidly processed. 2. The number of tokens it had to reject, as they did not align with your prediction. While the accepted tokens are handled efficiently, the rejected tokens are still charged at the regular completion rate. This dynamic creates an opportunity for strategic usage. The more accurate your prediction, the greater the potential savings in both time and cost. Conversely, an inaccurate prediction can lead to paying for the extra processing required. To further optimize performance, OpenAI has paired predicted outputs with their streaming capabilities. In the code refactoring example, instead of waiting for the entire response to load before receiving it, the API can deliver the output in real-time chunks. This allows you to display or process the information as it's being generated, minimizing any delay and enhancing the overall efficiency of the workflow. An additional advantage of predicted outputs is that the placement of your predicted text doesn't matter. Whether the prediction is at the beginning, middle, or end of the expected response, the AI can effectively latch onto those elements, streamlining the process. Let's consider an example in JavaScript using the Hano library for a simple server setup. Say you have the core server structure in place, and you now want to add a new route that responds with "Hello World." You can provide the existing server code as the prediction, and when you prompt the AI to add the new route, it won't need to regenerate the entire file. Instead, it can simply insert the new line of code, leveraging the familiar structure from your prediction to speed up the task. Now here is the catch. This feature is currently only available for the GPT-4 and GPT-4o-mini models, not the full suite of OpenAI's offerings. Additionally, certain settings are incompatible, such as the inability to set max tokens when using predictions. Features like audio generation, multimodal outputs, and function calls within the API also do not work with predicted outputs. Another important consideration is that even if your prediction isn't perfectly accurate, you'll still be billed for the full number of tokens in your prediction. While predicted outputs can save you time by reducing the processing required, they don't necessarily translate to direct cost savings unless you're strategic in crafting your predictions. For developers looking to implement this feature, the OpenAI documentation provides guidance on the specific workflows. For example, in a JavaScript TypeScript scenario, you would input your existing code snippet as the prediction parameter, then use a chat completion prompt to specify the desired changes, such as replacing a username property with email. The AI will then efficiently update just the necessary portions based on your prediction. Predicted outputs from OpenAI's GPT-4 models have clear practical applications for anyone tackling repetitive tasks. This feature really shines for bloggers updating existing posts, developers refining code, and data scientists making minor tweaks to datasets. Let's consider a real-world example of a blog post with a list of entries that needs updating. Instead of regenerating the entire post from scratch, you can pre-fill the sections that are staying the same as your prediction. The AI can then focus solely on inserting the new content, saving significant time in the process. The more predictable and repetitive the task, the greater the efficiency gains from using predicted outputs. OpenAI wisely advises starting small when experimenting with this feature. Test it on controlled, repeatable tasks first to get a sense of the time savings you can achieve. This also allows you to find the right balance in crafting your predictions. Being too broad can lead to rejected tokens and unnecessary charges, while being too specific limits the benefit. A measured approach to testing and optimizing your predictions is key to maximizing the value of this transformative capability. So what are your thoughts? Do you use this feature in your workflow? Share your insights below. If you like this video, hit that like and subscribe button for more AI tips. Thanks for watching, and see you next time.